So welcome to Transform Gov, the Digital Government podcast. And Transform Gov is part of the Ireland e-Government Awards, and it's brought to you in association with Accenture. I'm Maeve Kneafsey. Today we're looking at how public sector teams can finally make sense of complex geospatial data, like drone footage and 3D mapping, without needing to get tangled up in lots of different kinds of software and different kinds of servers. To make this real, imagine you're using AI and drone data to scan every single road in your county. Within minutes, in this new solution that we're going to hear about, you can pinpoint any overgrown trees that may be blocking traffic signs. And then you can create a clear list of priorities for your crews to go out and focus in the worst areas and get things sorted. So it's faster, cost efficient and easier to manage. So that's the dream anyway. So that's the kind of problem today's guest is going to solve. And joining us today is Alan Browne. He's CEO and co-founder of Soarvo, a cloud-based platform that's turning large volumes of geodata into practical actions. So Alan, you're very, very welcome to Transform Gov.
It's a pleasure to be here and thanks for having me.
Not at all. So for anyone who hasn't come across Soarvo before, in plain English, I know this is not easy, but in plain English, just explain what the platform is. It is a platform, a software platform. Is that correct?
It is. So Soarvo is a cloud-based platform that integrates diverse types of geospatial data into an interactive 3D environment. And because it is cloud-based and available through any browser, it doesn't require any expensive hardware or software to be able to interact with that data. And then that enables all stakeholders to be able to interface and to view and then to collaborate and then ultimately make the best decisions they can with that data.
I mean, I suppose in a way for us to get our heads around it, it may be useful for you to, I mean, firstly, you're hugely experienced. You've been in this kind of geospatial data world for maybe 20 years, maybe more. Maybe
nearly
more.
35 years now.
35 years. Shush, we won't be saying that out loud. But for a while anyway. But you must have been coming across some sort of problems that you weren't able to solve with other solutions that you said, hang on, we can do that. And just tell us a little bit of what those problems were. What were you seeing happening out there?
So, particularly, say, over the last 20 years, we've seen huge advances in the type of equipment and instruments that can collect the data. So we have mobile laser scanning vehicles, we have drones, we have, amazing video capture cameras that can collect really great detail. All that information has been kind of kept in silos and hasn't been mixed together to really get the best kind of insights that you can. And part of the reason that has been is because it takes a lot of processing for that data, but it also requires specialized software to pick out the different pieces. So we started, our challenges started, when we, another company I had, we were selling the equipment, the mobile mapping, and we were seeing some of the challenges.
Hardware. Was it the hardware? Okay,
the hardware to collect all that data. And as we processed the data, the big challenge was how could our customers share that data with their customers so that they could get the great insights. So their customers may be local authorities or road designers or something like that who are actually looking to see what they could do with the infrastructure that they have. So that was really what started us on that journey. And we had a product that we were using for various other types of data collection. So we started building it up to be able to handle all that. Okay.
So, I suppose in a way, people forget that being able to gather loads of data in a way causes another challenge, doesn't it? Because if you've got, as you said, geodata, if you've got drone data, if you've got data coming from video cameras, whatever it happens to be, to really make actionable insight from it, you've got to be able to consolidate it and use it. So give us a real life example in the real world, as they say, for where your solution has solved problems, and maybe changed the outcome for people who are using it.
Well, so one example in the UK with National Highways, we did a project.
Is that part of the Department of Transport?
It's yes, but they particularly look after the motorways in England.
Okay. So, not Scotland, not Northern Ireland, England. Okay,
or Wales.
Yeah, or Wales.
And they have a particular concrete roads program, which are roads that are coming quite near the end of life.
Okay.
These roads were mostly built in the 60s. They've got about a 60-year design life. So there's lots of challenges around those.
We can remember whenever you went over the border when I was younger, the roads were fantastic, weren't they?
Absolutely.
Much better than British roads.
Yes.
But now I don't think it's the
a
same.
little bit different.
It's
Well, we
different,
did an amazing job here in the early 2000s on building roads here in Ireland. So, that's something we could be really proud of. But so with national highways, traditionally where they're trying to find damage on those roads, they had a person that walked along the hard shoulder with a measuring wheel, and they could identify visually some, degradation or a defect on the road surface, and they would mark that down in a notebook, and they'd mark how you measure distance on a road is in chainage, and they have chainage points, and then they'd use the measuring wheel. So say the chainage point was 10,000 and they were 200 metres beyond that, they would say this is chainage 10,200, there's some damage in the fast lane, and they would then, that would all go back to the central office, and then there'd be engineers would look over that.
And hang on now, as well as that, right? I mean, I can think about all the problems that would cause. You can't have somebody walking the roads the whole time. So I presume it was a moment in time.
It's a moment in time, but it's also the danger of somebody who is walking down the side of the road. You've all the different thing in live traffic and so we had lots of interactions with National Highways about different opportunities to do things. So we actually we came up with a solution that the road was driven with a mobile mapping vehicle, and in particular for this application there were downward facing cameras that are taking images every couple of meters along the road surface.
So rather than Google Map, you're not looking ahead, you're looking down to try and see damage.
It was also picking up lots of other information. So there's cameras, there's laser scanners, so it's picking up tons of information. But for this particular application, we were taking these downward facing cameras. Now we had to do some processing because the cameras are taken at a slight angle, so that's an oblique angle. We had to put it in to create what we call an orthomosaic, so it's like you're looking directly down on this point. Okay. So it's like one large photograph of the whole road surface, and then we put that through an AI engine, which actually followed the National Highways rules. So they have rule sets for different types of defects on the road. Okay. So whether they have these names like scrimming and fretting and different things. So we actually were able to identify those different defects.
Based on the criteria?
Based on the criteria that they have.
A that's deeper than another one. It goes up the chart.
And it was able to pick out stuff that wouldn't necessarily get picked out with the human eye. And slight depressions, slight things like that are indicators that a problem is going to start happening. So that was then kind of, we created what we call like shape files around these things, and they got sent back into the portal, and then we could actually put those in front of. So this was the only real piece where the National Highways engineers looked at it, and they would look at particular areas and say, okay, there's too many defects in that area, we're going to actually have to redo the whole thing, or else they might say we will do spot repairs in those places. But again, through our system, they were able to send a work order out to the framework contractors to carry out the work. Gets carried out.
That's a proper specification. To do that in the old-fashioned way would be so much more hassle. I presume you can automate the deployment of the specification.
Absolutely. So the type of defect it has been sent so that they're prepared for in advance. They've seen a photograph of it. They've seen all the different things of that defect. But one of the interesting things is, again, traditionally that work's carried out at night time. There's a real challenge sometimes finding that place at night time. The guy has said it's 10,200, but
clicks.
You're using
clicks.
Exactly. Yeah. So you're not necessarily using the most accurate way of measuring. So we created a because we have that point very accurately located. We were actually able to, on a mobile device with a high accuracy GPS unit on it, they are able to actually navigate to that point using augmented reality. So they can actually see that point, and actually as they get to it, they can actually see the defect.
So you've made a virtual reality world for
it's
them,
actually
in a sense,
so it's very easy for them to see the defect. they can carry out the repair. Using the same device, they can now photograph and document the repair that they've done, and actually full validation the whole way through. That goes back to National Highways, so they can sign off that the work has been done.
I mean, which is really important, right, to the public sector. But in a way to make it come to life, what it reminds me of is some of the work that's gone on in medicine, because there's a lot more the doctor knows before he goes in and does anything, right? In terms of, or she does something. So where is it located? How bad is it? Can we see it in 3D? So you're really doing that for kind of infrastructure in a way.
Absolutely.
So that when the work starts getting done, the likelihood is they know exactly what to bring, how bad the problem is, as you said, where to focus. So I mean, I'm thinking about the Department of Transport and National Highways. I mean, they built a kind of a portal, didn't they, before anybody else really to look after their infrastructure. What was you bringing to them that kind of changed? Because there's lots of software out there doing different elements, isn't there?
I think in this particular application, it's always there's somebody who has an appetite and they want to see, they want to use technology to change. So the guy that was in charge of this program in National Highways, he immediately saw the opportunity to use the technology. But it saved a huge amount of money. They actually did the calculation.
There's the big word. We hear that. It saves a huge amount of money. Well, that's always a very good place to start, right?
So they reckon just in this method of working, it was saving them £5,000 per 20 kilometres.
Wow.
So over 1 year, that saved them £17 million.
Wow. Okay. That's amazing. Now, look, I have to stop because there's very important people I have to take a pause to thank, in particular our sponsors. So don't go away. We'll be back very, very shortly and we'll continue our conversation with Alan.
Through the power of cloud, data and AI, Accenture is helping the public sector by blending human ingenuity, technology and a delivery-focused culture to turn their ambitions into action. Be ready for any challenge by adopting a continuous reinvention mindset to deliver human-centric services that adapt and grow with your needs. Contact the team at Accenture to find out more.
So what kind of results, I mean, you've already told me to some extent, right, that the 17 million saving is huge amounts of money. But what other kind of results did you see as a result of that deployment in that particular situation with the National Highways?
Well, for them, there's a couple of things. So we're in a program where we've actually driven these roads like annually over 3 years. So we can actually see a couple of things. One, generally, how are those roads changing over that period of time? One of the things that actually you see with concrete roads, as apart from asphalt roads, is they take longer to start deteriorating, but when they start deteriorating, it's much more rapid.
Who would have known? Well, I suppose the planners and everybody out there who know this business would know.
Yeah, so because we've done it every year, it's allowing them to get insight and to see is actually how that degradation is happening. But also the thing is, they could actually test the different methods that they've used for the repairs, and again see how they are holding up. So it's an interesting. It's just giving them data. They can actually just slide a bar a line. They can see what that road looked like in 2022. They can see what it looked like in 2023. So this is, again, what we're talking about, trying to take all this information and just put it in front of the people that can make the right decisions.
I know, when we were talking earlier on, one of the things you were saying is that often with these, I suppose, software solutions or digital tools is the complexity in actually using them, right? So is your solution dealing with a lot of those headaches in terms of, I mean, firstly, the processing of all that data can be really, really slow and you have to have a lot of processing power to do it. But then on top of that, do you have to be really technically competent to use your solution?
So I think that's part of why we came up with Soarvo, and Soarvo is our new product. So the K-matic product which we had, which we started with originally, it was an evolution, and with the particularly in cloud computing, we hadn't built that from scratch, knowing what we were going to do. So we were kind of bolting pieces onto it to make it work. And it was effective, but it was like trying to build a really big building on top of not fantastic foundations. So we also saw the challenges that uploading all that data wasn't that simple, and then actually being able to the whole user interface wasn't that simple, because it was more an engineering type interface rather than a user interface.
Yes.
So they were things we really worked on. It's really easy to upload data. It's a drag and drop. And whether that's drone data, laser scan data, whatever it is, you drag and drop it in. We have all the architecture in place that we're spinning up servers as you need to process stuff, but it's shutting those down because this is a huge part. It's optimizing the cost in this because these are expensive machines to operate when you're using them, but we're using them in the most efficient manner, and that really is the thing that. The product we said we want to make it that you don't have to be a specialist to use it. We want to put this information in the hands of the domain experts.
Why did you want to do that?
So if you take the example of a highways engineer, he's not necessarily a specialist in geospatial and actually how to process that and actually how to get all the data in the right way. He's an expert in the materials and actually how a highway performs, the different types of designs. What we're trying to do is actually give him the best information he can have to use his great knowledge to make the best decisions in terms of how they're going to deal, whether it's maintenance or rebuilding of a road.
Okay, I can imagine, because sometimes, it's like if you're not used to looking at data presented in a certain way, you're going to need somebody else to interpret it, but you're trying to make it interpretable by anybody.
Absolutely, and it's even if you look at today, if you look at traditional drawings for a house, if you're getting an extension in your house and you're seeing plans and elevations, they can sometimes be difficult to understand. But if you just see a 3D model sitting in front of you and that you could actually navigate your way through that and put yourself standing in your kitchen extension, you can actually look around and see and that's really what we're doing with all types of geospatial data. So whether that's interior or exterior, we can handle all that type of data.
So who do you think are because I know this product has evolved, you've had a platform, you've got some really good customers, but who do you think are going to be the biggest public sector users of your platform? Where do you think it'll really start to make a huge difference? Well,
I think we're definitely seeing a lot of interest from generally the local authorities, because the local authorities have responsibilities for the national roads in their counties, but they have, again, they have had a lot of surveys carried out over the years, whether that's surveys on road signs. They get road sign conditions surveys done. They get the reflectivity of the road markings. They're getting inspections carried out on bridges. They're getting all these things carried out. We can put all that data into one place for them.
So in other words, let's say I'm doing my infrastructure evaluation, rather than having a whole load of different projects going on to look at the bridges, another one for the roads, another one for something else, you can do it all into one. We can
have it all in one, and you can so we can have things broken down by projects. We can have them broken down by location. We can have so you could have say you have a bridge, you've got roads going into either side of it, but you've done a video inspection of the bridge. We can have all that video information there that can be tagged, that you can make comments, that you can send work orders out from, and the same for the road surface. But also because you've got other things going on. You've got ecology things going on in the periphery of the road. We can actually store all that location.
What do you mean? Sorry, when you say that, when you say ecology, what do you mean?
So in terms of you have a whole environment in the outskirts of a road, like trees. You have the flora and fauna that are there that actually have to be monitored. In terms of that's another responsibility. So we can document all that stuff, and that is again all in the one platform that is easily accessible.
I'm sure that makes a massive difference if you're planning. I mean, just in terms of you're trying to budget for how much do we need to spend on roads, what's the 5-year plan or the 3-year plan or whatever, where are we? So just knowing exactly where you are, not just with roads, with all your infrastructure, and as you say, even the environment.
Yeah, and there are lots of solutions that do parts of that today. There's fantastic engineering solutions, fantastic documentation solutions and asset management. But it just doesn't pull them all together in a way that is really simple.
I know that quite a lot of the solutions that are around for a bit longer struggle with cloud because they weren't cloud native. But is cloud very important for your solution?
Absolutely.
Why is it such a big deal?
Well, one, because it removes there's a couple of things. if you have on-premise hardware, the challenge with that now in terms of security, maintenance, keeping up with all the latest upgrades, everything with hardware. So the cloud just makes that so simple. In our business, we've had servers for the last 35 years. Except in the last 2 years, we've now moved all our, our software,
no longer on-prem. Yeah.
all our accounting, everything is done in the cloud. Because it's kind of counterintuitive, but it's more secure.
Yeah.
If you have a secure connection into that cloud, it's more secure. There's multiple backups of it happening all the time. So in terms of your security, it's easier to secure than actually on-premise stuff.
And we're not going to go into all that because I tell you what, it's a minefield. But the fact that you're in the Department of Transport, which is an infrastructure, you must have passed the test.
So we have to actually do a lot of different things. So when we're in the UK, we actually have to, the data all has to be stored in the UK. Irish data has to be, stored in EU servers. Yeah. And then obviously if we're going into the States or whatever, that'll all have to be, data residency in the US.
It gets more complicated by the second, but it's all solved. So look, we need to do another very, very quick break because we've just opened the entries this year for the Ireland Government Awards. So I'm going to take a short break to tell you more details about how you enter. So there is really big news happening this week.
Go on, what are you saying to me?
Well, it's the important time of the year. It's the Ireland e-Government Awards. We are now ready to go. We're open for entries.
22nd year?
22nd year. I can't believe it's the 22nd year. And they get more and more exciting every year.
I think I've done all 22 years and it really is a great event.
It is. It's fantastic. I mean, firstly, it's great to recognise people who don't normally get recognised for doing amazing, amazing projects. And we've interviewed quite a lot of them on the podcast, Transform Gov, as you know. But the deadline, which is very key, is the 2nd of June.
And entry is easy?
Very, very simple. It's online. I think we ask only 5 questions about the project. I'm not saying they're easy to answer, but they're pretty straightforward for whoever's involved in the project. All online. Submit, off you go. And you can tick as many categories as you want to enter.
And closing date again?
2nd of June. So make sure you don't miss it. We're looking forward to seeing your entries. So we're coming back now to talk about this very exciting subject of being able to kind of mine the infrastructure and geodata being accessible and easily analysed at a cost and efficiency that it just wasn't there before through your new solution. So Alan was telling me, I was asking earlier on, who are the people, I suppose, within the public sector that are most likely to adopt usage? And we talked about the councils. But is it a really high cost? Because, when you talk about what the product is and how sophisticated the platform is, I'm immediately thinking, is it going to be accessible to a fairly small council, local council? I mean, are we talking big budgets?
No, relative to what they're used to pay, it's actually very low. So, you're talking, sub 10,000 for a fairly significant deployment of this. And then it all depends how much data that you're actually going to be using, how many users you're going to be having. But in terms of the users, generally, we have our system set up to be as many users as you need. The real restriction is actually how many projects that you have and that. But generally, because we're optimizing all of it, it's way more cost effective than traditional packages.
So in other words, if I look at my local authority or I'm some infrastructure, National Transport Authority, if I want to do a fairly small deployment, it's possible.
Absolutely.
Test it
absolutely.
in a kind of within parameters and then roll it out. That's completely feasible. You don't have to have a huge big upfront investment.
Yeah, and that's always the easiest way because you can actually get a total proof of concept and pick a finite operation to look into.
And look, I know that you're passionate about this because you've been working in this area for a long time. But what is it that you think organisations are actually missing out on in terms of not being able to analyse their data? What can you see slipping through the net?
You mentioned the whole medical industry, and it's kind of similar because we have so much data collected, but it's in different silos, so that people aren't able to get the best insight. So a little bit like you may have had an MRI scan, you may have had a different type of scan, but they aren't all necessarily being brought together at any one time, and different specialists are looking after different pieces. So that definitely happens in the engineering world and in the asset management world. So if we can bring all the information together and have it that it's really easy to, visualize, and I say, and be in the hands of the absolute experts, that they can actually then make the best decisions that they can make. That really is where we see the biggest opportunity.
And I suppose, like you said, I mean, there's different kind of, I suppose, tools out there gathering data all over the place. And in fact, you might be doubling up in terms of gathering data. So I've got a video that's is there for security on a bridge, but I've also got somebody else going in to audit the condition of the road. So, you're saying, look, let's stop duplicating, consolidate the data we have and use it for different purposes.
Yeah, and it is amazing how much information. So that is one of the other things that we have is the ability to connect IoT sensors. So, video cameras, we can have moisture sensors, we can have thermometers. So we can have lots of that stuff, around pieces of infrastructure, giving feeds. And because we have the ability to communicate, we can have alarms built onto that kind of thing also. So it's giving the most holistic view of infrastructure that we believe is possible.
And you've obviously worked with some Irish organisations, not just the National Highways in the UK and other organisations in the UK. Who else have you worked with here?
Well, we did quite a lot of work with MBI, National Broadband Ireland, on the fibre rollout. Mm-hmm. So again, they had a challenge in terms of they wrapped the fibre around the existing air infrastructure. Mm-hmm. So
you mean EIR?
EIR, okay. Exactly. So in some of the remote areas, there's quite a bit of vegetation that is encroaching on those wires. So they actually have to cut back that vegetation to be able to wrap the fibre around. So one of their big problems was understanding how much of that vegetation there was, because they tend to engage local contractors to cut it, and they didn't have absolute clarity on what was happening. So we again used the same type of vehicle, so a mobile mapping vehicle, mm-hmm. but this time it was the laser scan and it's a particular type of laser that's actually, so some of the beams are able to penetrate the vegetation, so we could create a 3D model of the vegetation mm-hmm. around the wires. So that enabled them to be able to actually, then we could create we had to interpolate where the existing wire is, but then we also had to extrapolate as to where it would be with the new wire, because it sags down when the extra weight of the fibre wrapped around it. So then we had to actually model what would be a 1 metre kind of cylinder around that kind of, and then you calculate the amount of vegetation that has to get cut. So there was some quite complex engineering in it.
Yes.
But interesting for MBI, they actually were a worldwide finalist in the International Project Management Awards just for that project, okay, because the use of the technology in terms of, and it saved them a lot of money, but it also gave them great clarity into what they had to do. Yeah,
so they could put their energies in the right place. Yes. Well, look, finally, your vision then for your business and for the product going forward. What are you hoping for?
Well, so I think in the product, we want to just keep building it to make it, accessible to more and more people. So anybody who is handling any type of geospatial data, we want it to be accessible to them, and as a business, we're operating in the UK and Ireland now. We want to roll out further across Europe, and then, into the States and further afield.
Well, if somebody wants to get in touch with you, how will they get in touch with you?
If you just go onto our website, you can just go soarvo.com, soarvo.com.
Excellent, really good. Alan, thank you so much for joining us on Transform Gov. It was really fascinating.
It's been an absolute pleasure. Thank you.
So thank you so much for listening, and please let everybody else know that you think might be interested in this episode. Share it with them, please. And also, I've got to thank some really important people, which is the team behind Transform Gov. So thank you very much to studio manager Peter Bryce, to our video editor Neil Horner, to sound engineer Lee Brennan, to videographer Louis Griffin, and finally, thank you to South Dublin Podcast Studios.